Okay. Let me get the title set here. I don't need this either. Rather the software. Okay. That should be good. We open Restream as well. And then I'll switch the view over in a second. Yeah, it looks good. Hello folks. I've been out for a couple of days. We had some rush order stuff, let's say, with one of our clients that we had to take care of. And we're still kind of on the clock in some sense. We have a lot of professional work to get done. The good news is some of it relates to self-play. I think I can say that much. And we already have a environment for self-play that's pretty good for research. So what I figured that we would do now is I would just do some streaming for whatever amount of time makes sense, and we will work on some of the self-play research. I will give a quick summary of what I've been doing so far in a few minutes. Let me see. Okay. So, I guess so far, what we should say is robocode. Let's show the environment off first of all. I have it on the website still. I think I have it on the website. Yeah. Hey, Liberty. So this is robocode. It's like this tank battle end. Let's see, can I take over for it? Yeah. So it's this tank battle end. You can steer the tank around. You can shoot bullets. You have this like radar thing. But it's set up in kind of an interesting way, such that there are actually a lot of different strategies. Like, it doesn't look like there are, but there are actually a lot of interesting strategies to this thing. And there are a ton of different scripted models available that people have come up with for this. And this is what we're going to use for our self-play. There have been some improvements since then. Let me, hang on a second. Let me read this first. Okay, this is good. This one up. How to find real weakness, huh? Interesting. Too hard to exploit. And let me set up another experiment and then I'll talk through this. I'm sort of in the loop of, running a bunch of experiments and they take a while to run, so I can talk through stuff I've done so far once I have it running. I think we need to do... Okay, we'll see if this does anything, and then if not, I'll consider it otherwise. So, here's the deal with the robocode. First of all, we have a setup that lets us train at 100 million steps per second. An 8 GPU setup. It turns out that Puffer 4 is just really, really fast multi-GPU. I sort of knew this, but then I kind of forgot that I'd done all the engineering to make that work. So, yay, we have the ability to run multi-billion step experiments very, very quickly. Second thing is we have a historical self-play setup, and I've been testing it on robocode, and the game is clearly non-transitive, meaning that you can take a scripted bot, you can train against it, that'll work. You can train self-play, that'll work. You can take the self-play bot and evaluate it against the scripted bot, and that will fail. But if you evaluate a self-play trained bot against a bot trained against the scripted bot, then that one will work. So it's kind of non-transitive. There are a bunch of different strategies. I need to watch some of the policies for sure. But self-play alone ain't doing it. Likewise, historical self-play. Historical self-play gets you consistent performance against your past policies, but it still doesn't generalize well to held-out policies at all. Domain randomization helps a little bit, doesn't solve the problem. Doesn't solve the problem. And like several different permutations of this already tried. Okay. So what do we do from there? Well, I'm going to try a couple things with exploiter agents. That's what I'm doing now, which is what happens if we train agents to try to beat the current policy. Does that get us interesting diversity and robustness in the policy? We're trying a few versions of this next. And if this doesn't work, then we'll see what the heck else we can do. I've gone through some of the lit on self-play, and stuff is actually a fair bit lower quality than I remembered. I actually don't think a lot of the techniques out there are particularly well established or particularly likely to work well. I do think that self-play is probably something that you can just force to work if you randomize sufficiently, but you're kind of relying on task engineering. The trick to it is you need to get something that incentivizes enough diversity in the gameplay, so it's able to respond to many different strategies, and that's kind of tough. That is kind of tough. Blah, blah, blah. This is, again, sort of the same loop I was doing before, where I am testing experiments with stupid codecs, but it's kind of just calling pufferlib at this point. There's very little code associated with this. Like, all the work is sort of done in Puffer already, and this is just writing, like, shitty analysis scripts over logs and stuff that are all throwaway. And then if we get something to work, we'll do a proper implementation of it. But self-play is actually something that we need to work, and relatively soon. And to be fair, it can be made to work on individual tasks, but we'd like it to be much more robust than this. Okay, here we go. Oof, wait, where's my, Hmm. $20 was 10, 1, 2, 3, 1, 2, 3, 10 billion steps. Like this. All right, we'll try this. Hello, Jess. We are attempting self-play things today. Oh, and yes, this is 106 million SPS. That you're seeing that correctly. Self-play agenda is I mostly want to understand today whether exploiter agents as a concept is legitimate or not. Is this something that actually fucking works? There should be basically an ideal end for it. Mixed results so far. These will take a little bit of a while, though. Because, like, let's see if I do... Oh, I think this is not, yeah, this is not training exploiters. Let's do this. What changed? Well, that so far the historical stuff is not working, Jess. I still think the league thing, the full league thing from Alpha Star, I'm actually still very skeptical of. And I'm very skeptical of this, but essentially I've just downweighted all of the evidence on all the different approaches recently. So, we're back to basically having no idea what the fuck potentially works, and knowing that we can get it to work on any individual problem, but with domain specifics. I'm trying to see if any of these various methods actually reduce the amount of domain hacking. I already did a little bit of DR on robocode specifically. So what this experiment is doing here, this is training for 10 billion steps total. And every 1 billion steps, it stops to train an exploiter agent for 5 billion steps. So it's very slow. But we're going to see if this works. EFSP didn't change much. Yeah, I'm trying to figure out, Jess, it actually seems to me, okay, so historical alone is fine for stability. You can actually get policies that get consistently better over time with just historical self-play. And that's, like, pretty cheap. It's a little bit of eng, but it's pretty cheap. That definitely works. At least, yeah, that definitely works. The thing that I'm less certain about, though, right, is the strategy coverage. You know, how do you actually get the bot to continue improving and continue discovering lots of different strategies? Oh, yeah, also, I think a thing that you might not have realized, historical self-play scales amazingly with more GPUs, because you just give every GPU a different opponent. So, like the, oh no, how do we train against 8 different opponents at the same time? You use 8 different GPUs. And that's basically free. So that was one little change that I added. That helped a lot. Super, super easy. That'll go into self-play? Well, it'll go into whatever version of self-play ends up actually working, Jess. We need something that works. Because this shit decidedly does not work. To give you an idea, okay, we can train, let me get this correct. We can train an agent versus a scripted bot very easily, okay? We can train an agent in self-play that beats all of its previous checkpoints. We can train an agent against the agent that we trained versus the scripted bot, and it'll beat that. But we can't take the self-play agent and beat the scripted bot directly. So it can beat the bot that was trained against the scripted bot, but it can't beat the scripted bot. It's very weird. That's what I've been banging my head against. Wait, were you doing this on robocode? What were you using? Like, what were you testing this with, Jess? Or did you have this with chess? Did you get that same result with chess? Because if so, that's the first I've heard of it. And also tried it with chess. Okay. Okay, so that makes sense then. So you can learn something that exploits the scripted bot in a sense. But it's actually a weaker overall policy. That's interesting. Well, we'll see how this goes then. It's cool to know that that's a thing, though, right? And the fact that we get the same result on robocode. I think robocode is actually a very nice end for this. Yeah, convert. We know Puffer's very fast. The guy that built it must be really smart or something like that. I don't know. Nice haircut? Thank you. I was sick of feeling like a woolly mammoth. Fat brain cells. Trained by Puffer. It's funny that this is like, oh, this experiment is so annoying. Like, man, Puffer's so slow when it has to train for 60 billion steps. I will get myself a shorter dev loop. We'll like just shorten the experiments or something after this. But I want to have like a couple high confidence results first. Yield some general. Yeah, so that's the point, Finn. This is a much better way to make progress on general self-play than doing it directly on the client end, and I can stream it. Also, everybody welcome Finn officially. Finn has joined us for the summer as an intern. Already doing some cool drone work. Also, yeah, Finn, let me know what you need. Like, let me know what stuff you need from me. And also, like, do not feel that you need to stay up super late because of the time zone thing. Like, you don't have any required hours or whatever. So if you're tired, like, go to sleep. I know it's a little annoying with the time change, but... You're complaining that you have to wait a day to get billions? I'm complaining that I have to wait a minute to get billions. We actually can get 1 billion steps in 10 seconds now, or 11 seconds, I guess, with this. It's pretty ridiculous. This is 80% done already. has already done 50 billion steps while I've been talking. I'm actually pretty confident now that this is faster than the original Dota training. I'm pretty confident in that. Like that we're now at the scale where we can train small models on one node faster than like the big scale up experiments from the labs. Hello, welcome. Okay, this should be almost done. So all we're looking for essentially here, right, is we're looking for consistently training exploiters that beat the main policy, and then the main policy learns to be robust to the exploiter agents, and then we're looking for held out perf. And exploration. Oh yeah. I will say though, Jess, I think that self-play aside, 4.0 is pretty much good enough for most tasks already. I really do not care about the GTA series at all. Self-play merged. I think so, yeah. But convert, it's like it is, but it's dev code. Like, I'm not saying this is ready. I'm saying I'm actively doing experiments on this. Robocode is, in my mind, Robocode is the correct env to be doing this on. Not Enterprise yet? Fair enough. Buffer 5 before GTA 6. Oh yeah, also, Jess, there was a bug with Robocode that was essentially invalidating all of the historical results on Robocode. So I fixed that, and it did get better. It got to the point where now it's at least, it's improving over time versus its past self, but it's still not going to held out. I'm literally just letting this thing run evals because I don't know, our stupid eval setup is bad. Mentally, I'm kind of, I guess the research stuff is cool and all, but mentally, I really just want to be done with 5, and I want to be on to Puffer 6 already. I think that Puffer 6 is basically just going to be me taking the time this project deserves to properly clean up the code and make everything very clean and usable and consistent. Yeah. Well, we don't really have a point for AMD kernels convert. We probably will have to do a better CPU mode. We'll see about that for sure. Need to write some articles. No research? I actually don't believe this one. I think this is kind of meme. I'm not positive on that one, though. Okay, cool. So we have exploiters that have positive win rates. But now the main is not robust, and then it doesn't generalize. Okay. Plans on bridging sim to real. Yeah, we have stuff on that, and Finn is actually Finn has work that will be on that topic as well. He joined us this Monday for internship. Mixed results. Actually, I think that's just fail result there. But then again, it's not winning against the exploiters yet. So I guess then the question is, can you win against 10 exploiter agents and still somehow be brittle? That would likely, in my mind, just invalidate the whole idea of exploiters. The problem is, at that point, we start running out of ideas, don't we? Alright, we've got 20 plus people watching. Start sending me your, start sending me references for your best no bullshit self-play stuff. Pure self-play doesn't seem to work. I think that it relies very heavily on domain randomizing the task to get the diversity into the data. Historical self-play gets you stable perf versus your past checkpoint, but it's still very brittle, and it's very easy to exploit, and it's also not even robust to like simple scripted opponents. Exploiter agents is what we're testing now. It's an incredibly inefficient idea, and the results are mixed so far. But this is what we need. We need better ideas for self-play. A lot of the lit on this is just like this really janky game theory heavy crap that's tested on... Well, I say crap because it's tested on very simple envs. What is the main use case? General self-play in Puffer. We want to have a, we want to have some version of self-play that lets us take competitive tasks and train stable policies on it. So it's not like we just have one game or one task in mind, right? Like, we need this for client stuff, we need this for research, There are a lot of M's that are like a lot of problems that are very nicely formulated as competitive self-play tasks. And we have to approach things very differently if competitive self-play is not stable. But I know it can be made to work. It has plenty of history behind it. Sweep ranges. Lower LR seems to be better. So Jess, if you see that your sweep is constantly selecting the very, very edge of one of the ranges, and it seems like you can't get good policies without having it be at the very end of the range, then the range is too narrow. So basic sensitivity analysis. Okay, it's just gonna run it for me. Fine. So this here is... This will take, what, probably 3 minutes? No, hang on. 10 seconds per bill. Yeah, 3 to 5 minutes. This is supposed to be 20 billion steps training against the exploiter agents from before. Hopefully this is fine. Yeah. So the question here, right, is we were able to train decent exploiter agents last time. We trained lots of exploiter agents, but then we weren't able to beat them. So if we just train against all these exploiters directly, is it possible to train against 10 different exploiters and still have a brittle policy? Are there public benchmarks? For what? For self-play algorithms? Yes, but they're very bad. And the problem that we generally have with Puffer in comparing to other works directly is we are able to train about 1,000 times faster than everybody else. So we're not going to go and take somebody's env where we have to spend 1,000 times the amount of compute in order to get the same result. Or more oftentimes, it's like a slow benchmark with a really simple environment. It doesn't really make sense for us to go and then run our stuff on other people's benchmarks because they're so slow. If there's a benchmark that we really like and we think is important, what we do is we port the benchmark into Puffer so that it's fast, and then we use it for comparisons there. I didn't really like any of the self-play ones that I saw, though. I think that the robocode env that we have is a much, much better benchmark than anything I've seen. Oh yeah, what the heck is the title here? Reinforcement learning research with Joseph. Okay, that's fine. Okay. This will be done in a couple minutes. I should have run it myself. That was sort of silly. Time limit instead of a steps budget. I mean, we basically do, in the sense that how did I choose 20 billion steps? I chose 20 billion steps because it was, like, the longest I was willing to wait on something. And when we compare algorithms, we actually do compare based on wall clock. We don't compare based on steps. That's actually built into our sweeps algorithm, and to my knowledge, we're the only library that has our sweep implementation set up that way, which is one of the reasons we're able to solve tasks so quickly. Oh, come on. Oh, I saw that. I think that I didn't like this paper, man. This is the recent one, right? This is actually, I think these are our collaborators, right? Oh, no, no, no. This is a different one. I saw this. This one was super jank though, right? This one was like super jank when I looked at it. It's just a ton of math formalism, and it's a ton of math formalism, and it seems like very oddly posed. Like anything that's based on computing an oracle is kind of nuts. It's like this theoretical framework for unifying stuff. I did forget this one. I'm super sketched out, though, by the DeepMind stuff in general. Hang on, let me answer one thing. Okay, Finn just sent over a reasonable idea. Very good. Um, yeah, so the reason I'm sketched out with DeepMind stuff is, in my mind, you had at the same time OpenAI and DeepMind solving problems of comparable difficulty, and DeepMind used really fancy methods and OpenAI used really simple methods. So I think that the methods are more of a reflection of the ideologies of the researchers than of what's actually required. The thing that I am a little sketched out on, which I think that both are likely to be equally guilty of, um, the key problem is, like, if the bot is missing something strategically, right? Like, it's missing some aspect of the game that makes it brittle. In both cases, you have the researchers sitting there watching their agents playing the game constantly, right? And they say, oh, that looks wrong. Let's change it so that that gets fixed. So I think that if I were to just even use vanilla self-play with the robocode, I think I could probably, like, pretty easily come up with something that would full solve it. But I would have to be tweaking the env, tweaking the env, tweaking the env. So I guess what I want to know is, to what extent on the algorithm side can we get some level of robustness versus to what extent is it, as soon as you have to do self-play, like, the strategic diversity issue is just unsolved and you have to do a bunch of manual work. World models, the guardrails for true long. I think that's troll. Yeah, that's troll, and that certainly doesn't solve the that certainly doesn't solve this either. Okay. Well, that's the question. I can look up this one. They didn't use human data at all on the capture the flag one, did they? This architecture was kind of interesting. Oh yeah, this is the one that had the cool web visualizer, right? Presumably this game here is... I mean, this is no more complex than Robocode, right? It's a pretty simple task. Plus RS. I mean, they can't... The thing that's annoying, right, is they say self-play and they put it at 0. What this basically means, we didn't even fucking try with our baseline at all, and we just went straight to doing the fancy thing. The paper PDF link is down. Robocode? It's this. We're doing 1v1 of this. It's a tank battle game. You can shoot projectiles, you can steer, you can move, and you have like both a gun and a radar that are independently steerable. And the observations are set up such that you can't see the bullets, you can only see when they're fired. So there's like a lot of heuristic prediction into where you think your opponent is shooting and where you should dodge. There are a bunch of different strategies. You can try to ram into your opponents, you can try to predict where they're going and shoot there. You can try to get close, you can try to get farther away. You can try to just dodge a bunch of bullets because it takes energy, which is the same as life, in order to shoot. You can shoot fast shots that are weaker, you can shoot slower, bigger shots. It's a pretty cool little task. This is Yetterberg. Right? I will say, this is a stupidly complicated method for only having played 450k games. That's nothing. So they must have just I think that what happened with DeepMind here is they just massively fucking troll on their engineering team. Because there's no way that you need, like, this is a tiny number of games. They probably have this super fancy method because they just don't have any data at all. 450k games, they're like 1 or 2 minute games, that's nothing. But we can literally train on this amount. We're probably doing more data right here in our run than they have in theirs. I remember noticing that they used like tiny amount of data in their thing. Is this the same thing? Oh no, this is different. Where's the RS thing? Okay, well, we're not going to be able to find. Reward shaping. Okay, so look, just self-play plus reward shaping. Gets them to here, it says. A little bit of insight, Jess? A little bit. We can play with the rewards as well. Kind of odd, though. We'll do that next, I suppose. We go back to basics. We can do population-based thingy, potentially. We'll see. Oops. Where's my OBS? This is from the partnership with Cerberus, isn't it? Cerberus is a cool company. Okay, that's just eval. Hopefully this gives us an actual result finally. I think we should decide based on this result. If it beats the exploiters well, but it loses to the scripted bots, I think we drop the whole approach. At least for now. I think that's like enough time invested, and we consider this unpromising. If it does reasonably well, we continue. Okay. Wait, so we beat all the exploiters, and we do terribly versus scripted. What are you making so many M's for, man? We got any? Oh, okay. Wait a second. What is this? That's kind of cool looking. You gotta actually like get some of these polished nice. Need jobs, so more projects. I think you need like fully like finished polished projects that can be used for research or like applied or whatever. We just mute all the jacks, idiots. Effing. Alright, I hear you. But you can't flood me with N's, man. Like, you can't just flood N's in. We do need N's, but like... The lock N possibly, actually. We need M's that are especially interesting or challenging versus what we have in some way. Okay, I mean... That's pretty damning, right? That means the exploiter idea sucks. Good luck in ish. So, I think that that is reasonable. In my mind, they're just very brittle. So, like, these exploiter agents aren't really... They're kind of just exploiting, like... They're not exploiting, like, high-level weaknesses as much as they're just, like... Very nitpick things that, you could very, very easily train against. Okay, whatever. So that's fine. I haven't done much lately, Anish. what do we do from here? Exploiters fail. Well, we go back to vanilla self-play. It's been long enough, Anish, that people aren't just asking me shit constantly. What environment it's self-playing? It is working on robocode, which I think is a perfect environment for this. You can look it up. We have a port of it to C that's super fast. We can train at 100 million SPS. So wait. Ryan, I don't think that they do anything. From the recent experiment, it seems the exploiters just don't fucking do anything. Because if you can train 10 exploiters, and you're training it, like, the way I did it is, the policy trains for 1 billion steps, and this is a very nice big experiment as well, right? Because look, 100 mil SPS training. So this is a pretty, like, large-scale result as well, I would say, on a hard environment. You can train for 1 billion steps, then you train an exploiter for 5 billion steps from scratch, and you repeat that 10 times. You get a good policy for 10 billion steps. You get 10 exploiters that did well against the checkpoints, but you have a policy that does well against all the exploiters at the end. And that policy is crap against holdouts. So, and it's not even, like, meaningfully better against holdouts either than just doing normal self-play. Why not train on use cases in medicine? That is where we're eventually going. That is actually my biggest goal for Puffer, is to get it into biological sim. But I don't want to do it in a way that's bullshit, right? Like, that is actually some hardcore molecular simulation development work. And I want reinforcement learning to be a stable, consistent branch of ML, essentially. I want our stuff to actually work consistently and not feel jank. I think we're less than a year away from that. You train the final policy on self-play? Yes, I did self-play plus exploiters. Fine-tuning display from base policy. Yeah, I think that it's worse to fine-tune, though, Ryan, because the point of exploiters, right? The point of exploiters is that you want something different from the main policy, and you want it to just, like, look for what is the easiest way in which you can beat the specific main policy at the moment. You're looking for shortcuts, and that, I think, is better done from scratch. So yes, you could possibly speed it up, but I think this was, like, the cleanest test I could have run. And keep in mind, I didn't have much faith in this approach from the start. I think this is like I gave it, like, a reasonable chance. It's a absolutely god-awful method from a perspective of computational efficiency anyways. So, and I think that it is very likely that in AlphaStar, they got a lot of the data diversity from bootstrapping human data up to Diamond. Also, we know that DeepMind uses way overinflated methods anyways when they're not required at all. So I don't think that the evidence behind that method was particularly strong to begin with. The historical self-play on its own is at least producing policies that consistently improve over their past checkpoints. And I think that the recipe for Dota and for emergent tool use was just like that. So you have agents that are consistently improving over time, plus a manual loop of looking at the environment, seeing what the agents are missing, and screwing with reward functions or domain randomization. That's probably what happened. Yeah, I remember. Hey, Muhammad. Exploiters learn real strategies. Only wins against their self play. And more to make the player do real strategies. Yeah, but the point, I suppose, Ryan, was the exploiters are, that's the namesake, right? They're meant to exploit. It's not supposed to be a real strategy. It's supposed to cheese. You're training cheese agents. Um, and the question, right, is just beating a whole bunch of different cheese agents, does that actually let you have a robust policy? And the answer is no. Like, if you get different strategies that are bad but are outside of your distribution, it does not make you robust to those. This technique does not seem, at the very least, it's not something that you sneeze in the direction of and it works. Also, if I may advertise for Puffer a little bit for you here, if you want to do your research at 100 million steps per second, there's only one library that lets you do that. So, 100 million step per second training. uh, Exploiting an episode doesn't improve policy, achieves the best result. Like an episode. Exploiter agents are just agents that you're training against a fixed checkpoint. So the idea is because it's training against another fixed policy, it's just training to beat it in whatever the easiest way possible is. It doesn't have to know anything else other than how to exploit this one policy. Interesting. How did you do this? How do you connect multiple machines? Oh, isn't that's the funny part, Liberty? We don't. This is on one machine. 8 GPUs, but one machine. Puffer's just really, really fast. So yeah, you want 100 million step per second training? That'll be $4 to $5 per hour. How do you see safety in sim to real? What methods work best? Um, I mean that's very, very problem dependent. Like there are problems for which safety is not even remotely a concern at all in sim to real. And then there are problems for which is a very large concern, but then the concern is not even in the sim to real, it's in the behavior in the sim itself being unsafe. Like, that's too broad of a thing. say for self-driving. Actually, there was just a very good paper published on that. Very, very good paper. In fact, if we use any method for imitation whatsoever, it'll be this one. Where's it? This one right here. This is very, very good. Obviously, agent will be very exploitable without them. No, it won't. That's not obvious, Ryan. They didn't do it with Dota, and Dota beat the top team in the world. And then they ran it against, they ran that agent against, like, everybody for a weekend, and the only people that could find cheeses were, like, top elo players exploiting niche edge conditions. Like, there was not a single group that I saw of low or mid elo players being able to win under any circumstances. I think this is more so like the, oh, obviously it'll work, it won't work without this. That's a deep mindism. They found niche edge conditions. No, but Ryan, like, there were 0 instances of low or mid elo players being able to even find an exploit for the top Dota bot. A few players were able to win with like a max elo stack of players. There were no like easy cheeses, none. And that's just from historical self-play. Plus domain randomization and reward shaping, obviously. I think of all of the results in the field, that is the strongest. The hero pool. The constraint, no, that's not true. That's not true. Look how well this thing scales. People need to actually read this paper. This is the best paper in the field. Okay, look how well this thing scales. Okay, 5 heroes. Look at these curves, right? 5 heroes, 10 heroes, 17, 40, 80. You see this? So the constraint was essentially on compute. And this thing was scaling very, very well. Like, you'd expect it to be much harder to learn this many heroes. It actually was scaling amazingly well. It's just that by the standards of the time, and without the level of engineering that we have for RL nowadays, this was already like $10 million or whatever to run. But the scaling was very clear here. There were some constraints, but very few, and they kept removing them every update. It was mostly stuff just being hard to, like, literally hard to put into action space. By the time they did the game, it was pretty much the full game. Like, most of the constraints were from early versions, and they just kept consistently removing them. Mechanically hard. Not playing them below diamond, but they're exploitable in strategy space. Dota is a lot less so that than StarCraft, Ryan. Like, Dota's basically old man's League of Legends. League of Legends. How? Okay, so it doesn't really learn anything without reward shaping, it seems. Is there a reward at all? It's too hard with 0-1 reward, it seems, in current hypers. Which makes sense, looking at Gamma and such. Okay, I'd buy that. Really hard to bring about variety, yes. I think it's the variety is the key issue. And actually, I actually think that that's the reason that Dota scales so well with many heroes. Um, yes, you have to learn lots of different mechanics, but this scales way better than humans do, right? Like, having people play 80 heroes, good fucking luck. I actually wonder what the elo gap here would be. You know, like if you just put people on, if you have to have a pro player play like one of 80 heroes, if they have a bigger gap than this. Because I think that this is essentially just giving you more diversity in the training data. Historical. So that, Ryan, that seems to be true. At least historical self-play on its own doesn't. But they did so very well with Dota. So I think it's the combination of the game having diversity plus domain randomization plus rewards or something. But the thing is, the exploiter agents also don't help cover the strategy space from the last experiment. They seem to just suck. No, Jess, I think that's troll. That is fixed just by historical. Obviously, Alpha Star. Yeah, but I really think that, like, oh, this method works for DeepMind is a very weak signal, Ryan. DeepMind was like, they love throwing fancy methods at shit for no reason. That's kind of their whole shtick. Like, I believe that their stuff works, but I don't believe that it's necessary. And, like, the thing is, it probably doesn't work for the reason that they say, either. Non-transitive don't matter. No, the non-transitive strategies, that matters a lot. And in fact, we have very clear evidence that that is occurring in robocode. But, like, you just fix that with historical self-play. That part is fixed. Yeah, but Ryan, if you beat all of your past checkpoints, you've solved that, right? If you have no cycles whatsoever in your training, if it's just monotonic improvement, then you've solved that. I bet you it's the reward function. That would make sense to me, right? Think that works, yeah? I agree. do PFSP. What is the change, Ryan? Does that prioritize weight by win rate? I looked. Spencer said that didn't help very much, and also I looked at the Dota paper, and the distribution is basically flat if you look at it, anyways. Also, isn't that something different as well? Isn't fictitious different from historical? That's P. I'm never sure if there's a. I was never sure if there's a difference there. Fictitious is a really stupid name, though. I'm not gonna use that. Whoever came up with, like, that's a dumb name. This is the paper that I trust the most. So let's just take a look at data points, right? So, emergent tool use works with normal self-play, not even historical self-play. Dota works with historical self-play. The DeepMind papers that are known for using fancy-ass methods use fancy-ass methods. Okay, I know prioritized self-play, obviously. The fictitious part I don't know about. I know the prioritized historic, though. Fine. Yeah. So Spencer, the latest is the exploiters don't do anything. Learning 10 cheese strats doesn't actually give you a robust policy. And I'm suspecting, if anything, that it's likely... I think all the magic is in the rewards and the domain randomization. That's my expectation. Oh. I was wondering why I had no spoons for my soup. They put them with my pastry. Maybe, Spencer. I suspect it's more likely that the reward shaping that's used to get you to play against a scripted bot is essentially just locking you into one strategy. Oops. This. Maybe quick sweep. KL divergence as a heuristic. I don't see how. How do you know what 10 exploiters are learning to exploit and not learning something? So you don't know that they're not learning something very similar, but if they are learning something very similar, then the algorithm is bad anyways, right? Also, training exploiters is like a horrendously inefficient algorithm. I was only testing it in case it was like, oh yeah, this instantly just works. That's not suspicious, Spencer, because I have self-play off. So the frozen bank should be, not used at all. I also did confirm that you're getting different results with historical self-play. I fixed that error. I think it still just tries to load the policy even if you have the damn thing disabled. I mean, I've been able to get policies that basically monotonically improve versus their past checkpoints. That part of historical self-play works. Mm-hmm. Spencer, did you verify across three M's by running like a big tournament with all of the checkpoints, or just by the elo metric in the logs? Because the elo going up metric doesn't actually mean that it's improving. I confirmed that that metric can go up even if you're getting worse against past checkpoints. Tourneys? Okay, good. So we have a way to improve over past policies. That's good. Annoying. Losing to 25 but beating 70. Yeah. When I calc elo across all of them, the later policies are better. Here we go. True skill's not better than elo. Like that bit me very hard during my PhD. I absolutely hate true skill as a metric because of the way it adjusts variance. It doesn't produce you a true skill does not produce for you a reasonable like X point elo difference equals X skill difference thing. It produces this really, really unintuitive metric that's hard to analyze. Yeah, I did all that stuff, Kinvert. It was annoying. Mm, look, you can use basically... It kind of complicates it if you want to use one of the fancier metrics. Because you can't use them for... You can't use them for ranking. You can kind of only use them for MMR. I think what a lot of the games do is they have a visible elo, and then they have an internal MMR that affects how many points you get or lose per game. Because the thing is, the internal MMR is, like, completely unintuitive. Yeah. Because, like, nobody wants to, like, load up their game of Overwatch or whatever and see, like, oh yeah, your true skill increased by 0.3 or whatever. And then the next, like, 100 games later, it's only increasing or moving by, like, 0.05 per game. And it's like, it's not the case that a difference of X points is good or bad. But you need the visible elo because the internal elo makes no goddamn sense. It doesn't matter if it's more correct, if it's meaningless. Like, if I say, hey, there's a 2-point true skill difference between these two players, you have no idea what that means, right? If I tell you there's a 200 elo difference between these two players, you know, okay, this one wins 3 out of 4 games. You can use those methods internally, but you still end up needing a visible elo. This might be too sparse. This might be too sparse. I'm just seeing if we can get some hypers in a few minutes that will beat the scripted bot without reward shaping. Because I'm kind of... What I think is happening is we're just reward shaping it into a really aggressive, dumb policy. That is the question. And actually, will this finish in a reasonable amount of time? Also, how confident am I in this? Why don't we take a moment to just go over like the possibilities here? We'll go over the possibilities real quick, and then I'll take like a few minute break while I go get my vitamins or whatever, and then this runs for a little longer. So we've done pure self play. It can work, but it is unstable. And for complex games where like A beats B, well, non-transitive games, we should say, where A beats B, B beats C, does not mean that A beats C. That's non-transitive. Um, you need something to smooth it so that you don't forget how to play against previous policies. We do find, and I think we have very conclusive results, that historical self-play fixes this. So maybe you can very extensively tune normal self-play, but in this sense, historical self-play seems to be a very good algorithm. Now, the problem is that improving against yourself doesn't actually mean that at any reasonable rate you are learning to be better against even relatively easy held out opponents. That is the major problem we've seen thus far. Now, I will say, it doesn't look like this has been a massive issue in either of the top trustworthy, I would say, papers that I'm referencing here. Um, it's possible that the authors of both Hide and Seek and Dota were just kind of like looking at the policy, seeing what it was doing, tweaking the reward function, tweaking the env, and doing that on loop until it worked. I would think it's very likely, though, that we are somehow locking the policy into one very specific way of playing the game via the hypers and the reward function. That is what I would expect. So I think the first order of business is to see if we can get something more generic that doesn't use a super engineered reward function. Maybe just uses like win the game or whatever. Um, I think the reward conditioning idea is pretty solid of like training different policies on different reward functions and seeing if putting those in a population gets you a robust policy. I think that's pretty likely. Obviously, we know that if we allow ourselves to train against the scripted policies, we win. How do we evaluate what should go into the pool then? Like, how do we evaluate what should go into the pool? Or do we need a pool? There's the populace-based training thing that's kind of trolly. Repeat the question. It's more of amusing than it is a question, Jess. So, I mean, the issue that we're having, right, is lack of diversity in behavior in self-play. I'd already did try sweeping versus bot 1. I don't know if that sweep was very well set up, though. I think maybe we just, what we do today is we play around a little bit. We see if we can get a reasonable set of a reasonable policy with rewards that beat bot 1 without shaping. or at least do decently. We run self-play using those hypers. We run some evals on that. And then we probably just want to go port a bunch of additional bots for robocode and build a robust eval. I think that's going to be it. We build like a robust eval. We have like a nice held out set of robocode opponents then. And we basically just sweep self-play, where the entire training is historical self-play, but the eval is versus these bots. That's probably the most reasonable thing, if I were to guess. It's a little annoying though to sweep because self-play, historical self-play in particular, is much more efficient on multiple GPUs than it is on one. Like, historical self-play on one GPU kind of sucks. Because you have a different opponent on each GPU, so you get much more diversity in the data. It's a nice trick. Oh, hey guys, there you go. After a couple of minutes already, we have a... If this is to be trusted, we have a perf of 49%. So it looks like... This 5 billion steps. Okay. So, I mean, it looks like we are actually going to be able to find something reasonable here. Python may feed eval into observe to navigate sweeps. Well, yeah, we can do that, Jess, but we would, like, once we refactor, like, once we have Puffer cleaned up, we'll just be able to do that end-to-end in CUDA C. Okay. Yeah, I think what I'm going to do is I'm going to let the sweep continue for a few minutes. I'm going to go grab my vitamins and walk around for a couple. And hopefully we'll have a decent enough config in a few minutes by the time I'm back. We have quite a few people watching, actually, at the moment, so thank you all. I'm going to leave the stream up, and I'm going to be back in just a few minutes. But if you are new around here, I stream pretty much all of my dev. And if you want to help us out for absolutely free, puffer.ai, start the GitHub. At 6K stars, it really helps us out a lot. You can join on Discord to get involved. You can also follow me on X for more RL content. I'll leave the env up, actually, on the screen, because this is the task that we're using for training. Obviously, this is a crappy policy. I'll be right back. All right. Same experiment. Nothing new. Is this the default? I think this is the default, right? Does it just run the default for 5 bill steps or whatever? Which we know actually does not produce good policies, huh? See, the problem is these are janky hypers. Okay, I mean, we have stuff we can do in the meantime. Experience replay stratified, sampling over. Our 4.0 replay is it's advantage-based sampling of the trajectory segments collected over a single epoch. Is this bullshit? Yep, bullshit. Oh, geez, they didn't port it. Heh. Yeah, so this is... Okay. Um, where did they have this before? Okay, here. Gradient descent in targeting and surfing. Yeah, I remember this. We basically want like something as simple as circular targeting. Okay, grabbing the random jar file for this, sure. I don't know why it's doing this, but cool. Where were like the basic microbots? I'm using a robocode crit. I remember there being a ton of these. There's wave surfing, there's circular targeting. There's a whole bunch of basic ass techniques. Okay, here it is. It's just grabbing a bunch of things. That's fine. There should be a ton of bots for this. I'm basically what I want to do is just get Codex to port a bunch of the a bunch of random ones. Get like, I don't know, somewhere between 5 and 10 different bots to eval against, more than the 3 that we have, and to have like different levels of difficulty to them. Not open source, I see. So some of them are open, some of them are not. Okay, so they've just all come up with a bunch of heuristic methods, right? One for shooting. What does that do for you, Liberty? Like, why? Hmm. How's this going? Still here. Hmm. Wave surfing. We also... Hmm. A lot of heuristics. I wonder if we can run these directly. We probably can't. Because we don't have Java. Yeah, that sounds bad. Let's do, easier to find out which versions in the pool are better. Not particularly, and they're also kind of joint. Yeah, no, we have source for most of them. Well, it can be in like jar. It can contain source. It cannot contain source. Work in and create new M's or use existing M's to develop algorithms. Well, both, and we do both. I mean, Puffer's kind of a comprehensive effort for a lot of the problems in the field at the moment. So we do algorithm dev on Puffer using high confidence environments that we've built or ported. And then we also, we take whatever the current version of our algorithm is, and then we try to build new environments to solve specific problems that we care about. Yeah, I think this will be the reasonable thing. So we get a larger eval set. Probably this thing makes a massive mess, but as long as it doesn't screw with our core code, we don't really care. As long as it doesn't screw with the core env at least. We end up with big eval set. Any of the ones that don't work or are super slow, we just trash. There should be, there's a lot of old, really legacy Java for this. So there should be good reference. And then I know of a couple basic bots that we should probably include as well. Ocean, multi-buffers, and my Python bindings. I think I did that, Pepper, didn't I? Like, you have that in, if you look at the puffer for, like, puffer, was it torch pufferel or whatever, that pi? We use our own vectorization, but with torch models. I have no idea whether or not I will bother keeping that in like Puffer 5 or 6, but for now it's there. It's just getting to be increasingly the case that like, oh, what if I want to do it with Torch? Well, you're kind of trolling because it's super slow. Hmm. Wait, so just randomly a couple people submitted new bots? To use Puffer in production? Depends on what you're trying to do. I mean, you can train our bots and then deploy them however you'd like. Um, Typically, it's going to be if you have a slow env and you're kind of trying to do some RL with it, you write a fast env and then you train on that. We also offer simulation engineering professionally. It's actually the main thing that Puffer the company does is we help other companies build very high performance simulators for their problems that are compatible with Puffer. Obviously, you can do it yourself as well. Losing Puffer adapter in the future. Well, it isn't Pepper. Like, it gets to a point where it's like, cool, you can train in Torch at like 1,000,000 steps per second or whatever. But now Puffer trains at 20 million steps per second, right? So you almost like you get a completely wrong impression of what Puffer can do if you're training that slowly. Like you're literally working in a different field. Um, every time you like go up in order of magnitude in perf, especially with the new algorithms, like the new algorithms that actually require custom kernels to be done stable and efficiently. I will say that when eventually we get like a native like end-to-end CUDA-C version of Puffer with no Python, it will be quite simple. I think arguably much simpler than the Python is now. It would probably be a mistake for us to release Puffer ever with like no Python binding or whatever, but we'll probably end up releasing a version where you can just run end to end without Python and you don't require Python for setup at all. Just write the envs and the algos. And, well, we have, yeah, the envs you definitely want in C. And then we have our algorithm. Our algorithm's already state of the art for the type of RL that we do, so you can use that. And then on the research side, yeah, we pretty much just extend the current stuff. Keep in mind that most things that you'd want to do end up just being like very basic C. The exception being, I suppose, model development. You can prototype models in Torch for sure. That's fine. I will say, though, that if you're thinking about what models are good and efficient and you're only thinking about them in terms of Torch, you're going to get the wrong answer. Like, for example, the model that we have in Puffer 4 that is state of the art that like solved a bajillion different problems that we couldn't solve before, that that architecture is not possible to implement efficiently in Torch. Like literally Torch is so bad it restricts the types of methods you can even use efficiently in a way that your hardware does not. So that's kind of one of the reasons why we've gone lower and lower level. You literally prevent yourself from considering a demonstrably useful set of architectures and algorithms because the things that can be made fast in Torch are a small subset of the things that can be made fast on your GPU in general. All right, what's going on here? Oh, we're running more of these, but just none of them are outperforming yet, I suppose. So I'm just basically letting this thing try to port some agents or whatever. Um, I figure I can do this, like, this can do this while we run some experiments, and then we're going to go back to self-play. I mean, it is and it isn't, Pepper. Like, the vast majority of papers I see in RL end up being wrong, like straight wrong, useless, because they run very inefficient code on very easy problems, and then they attempt to draw conclusions from that. Like, you can't just go run a really fancy algorithm on a really easy problem for 10 million steps with horribly unoptimal hyperparameters on both your method and the baseline and expect to draw any reasonable conclusions. Could your work not include way more CUDA? It's CUDA C. There is CUDA. Actual models. Uh, Check this out. So it's CUDA C, right? We're technically compiling the whole thing as CUDA. This includes the CPU launch code and all the algorithm stuff. That's more or less just C, but the kernels are also just sitting right in here. And the architecture that we have is all custom kernels. But the thing is, because we don't have any sort of attention-based stuff in our architecture, the kernels don't actually include matmols. So there's some complexity to them, but they're much, much, much simpler than they would be if they had to include matmols in them. Like, we can basically just call cublast matmol, and then it's all of the activations and the loss and all the other sort of intermediate plumbing that needs kernels. It's probably like 95% of them, Pepper. Self-play, like AlphaGo. Versions of self-play are used in like AlphaGo, OpenAI 5, AlphaStar, Hide and Seek, Emergent Tool Use, Capture the Flag, all the big works from like 2019-ish era RL were self-play. And there were a lot of confusing, there are a lot of confounding variables around what version of self-play you actually need that works and is simple. That's what we're attempting to figure out now. We're using RoboCode, which is this 1v1 tank battle environment, as a benchmark. We're running large-scale experiments, like 20 billion steps of training, because Puffer is very fast. And we are attempting to figure out how we can get agents trained just with historical self-play or whatever version of self-play we end up using to generalize to a bunch of held-out policies. So we're going to train versus itself and then see if we can beat a whole bunch of scripted agents that are being, well, attempting to be automatically ported over from Java, because there's no way in hell you're going to make me manually port 20-year-old Java code to C. But while this is happening here, right, we are running some experiments on the sweep. I'm hoping we get some better hypers out of this. We will see. But otherwise, this will just be whatever garbage code. System, I definitely do things differently because this exists. I definitely do that. I try not to, like, this stuff you see on the side here, I try very, very hard not to let this screw up my main code base, because this always writes unusable garbage code. And if I just kind of let this add stuff to Puffer and add stuff to Puffer, the whole project would very quickly become worthless. So the version of this that I'm doing at the moment is like, I get to try out crazy ideas much more quickly, with not perfect confidence, right? Because sometimes this just implements stuff wrong or whatever. But a positive result is usually good. So if I try a crazy idea with Codex and I get a experiment with Puffer that works, then I dig into it, and then if it works, if it actually ends up holding up, then I will manually rewrite a version of it that actually can go into the Puffer codebase proper. So it lets me run a bunch of like medium confidence-ish experiments pretty quickly. It's definitely not as good as me taking the time to do it by hand. Like, it makes a lot of really dumb mistakes, but it does let me go through a lot of different ideas quickly with good enough confidence most of the time, I would say. I will say that this is a completely boring. Like, I absolutely hate working this way, so I basically get no enjoyment whatsoever out of my job whenever I'm working this way, and I end up taking a lot of time off because how much this sucks. Like, I really, really, really would like to just be writing, like, manually editing our our core code base at the moment and fixing little things, improving Puffer in various small ways. Like, that's infinitely more satisfying to me than whatever the heck this is. But you know, unfortunately, if I have to have a miserable workday in order for progress to be made on Puffer, then I just have to have a miserable workday. How are most of the RL papers wrong? Um, so most RL papers are trivially wrong. If you just go to your typical conference, what you will do is you will go and see a bunch of very simple very simple environments where they're training for 10 million steps, and they do 20% better than the baseline, and they've not hyperparameter tuned the baseline, and they've spent like 3 months tuning their method. That is trivially wrong, because if you do any hyperparameter sweep work whatsoever in Puffer, you know that there's much more than a margin of 20% just in the hyperparameters alone. Much, much more. Hang on, I missed a bunch of questions here. Computer vision torch only PhD student. So yeah, that's very common for researchers to not be able to get deep enough into Eng. I will say that the stack that we have here matters a lot more because of the model sizes in RL. So Torch is relatively much more efficient for models than the hundreds plus millions of parameters. But when you're down to like single digit million parameters or lower, you really need the custom stack. RL JEPA, no. JavaScripted code is like typically used in the enemy game AI for eval. Yeah, so the way that this game works, this was a programming game that was used like 20 years ago. Actually, when I first learned to program, this was one of the things I was shown. The code base for the original RoboCode game is some of the worst code you'll ever see. And it's basically taught a generation of programmers how to write terrible code. But the game itself is pretty cool, and there are a whole bunch of different agents out there, or scripted bots, that have a bunch of different strategies. It's really old, bad Java code, but I figured that since we have RoboCode ported to C now, we can probably get Codex to just port a bunch of these bots, because I care about the quality of the environment code, but I don't really care so much about the quality of random eval bots. At least not initially. Puffer main is AI gen. Like actual AI gen, almost none of it. I spent like months painstakingly going through by hand and fixing. We had a bunch of PRs that were also like people doing kernel search and crap. I went through a lot of that as well. I think even like the little bits that are still kind of like chunks of this kernel, chunks of that kernel, or whatever, I still need to go through more of that by hand. But I do mean it when I say that, like, if I were to just take, like, the Puffer 5 code, for instance, which is um, me using AI for experiments, and if I were to just commit that as main code, you basically just destroy the project. There's essentially no point in having all of this if the code base is crap. Like, you actually, like, the whole point of Puffer is you understand exactly everything about what's going on. It's an amazing code base for research. Sure, you know, it's 5,000 lines of CUDA instead of 2,000 lines of Torch. But what you don't have is 3.3 million lines of unreadable garbage Torch source. So the perf versus simplicity trade-off is a real thing. But I think we're gonna be able to get, like, probably Puffer 5 to 7,000 lines of code for the source, with all the new algorithm stuff that I need to be in there, all the good evals, and quite clean. What am I doing? Wait, not do 3 hours of real coding. It's getting embarrassing. You need a project from scratch to work on. See, the thing is, like, the big problem with AI code is it's so dog shit that, like, it's normal to not be able to edit AI gen code. Like, they just output such complete garbage. Like, that's normal. You should be able to write stuff from scratch, though. Like, I can still write stuff from scratch, and I way, way, way prefer that. Like, I would like nothing more right now than to just be able to go build an end from scratch, or build, like, a new thing for Puffer from scratch, or whatever. But, you know, unfortunately for the research side work at the moment, this is relatively more time efficient. And this still does not, like, keep in mind, this does not end up polluting the code base at all, because we're not actually merging any AI gen crap, right, into the main code base. This is all experiments for figuring out what the algorithm should be. And then once we know what the algorithm should be, I will write a clean version of it. This is like, here, this is me trying to answer questions like, you know, is normal self-play stable? Do you get monotonically increasing performance over checkpoints with normal self-play? No. How about with historical self-play? Yes? Okay. Now, if you evaluate both of those versus these specific scripted bots, does it transfer and is robust? No. Okay. Does robustness increase as you train for longer? No. It's completely decorrelated. Okay. What about this other question? Right? And it's just me, like, iteratively asking questions like this. That's pretty much what I'm doing. It's a little disappointing that we have not found any better configs yet. Code RL, what the heck? Hang on. RLP RL. Okay, so RLVR is, like, irrelevant. That's language modeling shenanigans. We always have verifiable rewards in normal RL, and we have much stronger algorithms. Torch has very fundamental differences that really for any small model work, though, you know, particularly with the env in the loop, Torch just has a huge amount of overhead, such that it is very, very inefficient for models below a certain size, and the vast majority of models that you use in RL are below that size. The whole rest of the RL stack that is built around Torch, external to Puffer, is essentially you have to throw it all away. There's not a single aspect of the historical RL stack that was done efficiently, which is why we over time have rewritten the whole thing. You need kernel code for everything with Puffer, but also the kernels need to all be fused and CUDA graphed. So Torch just has a million different kernels with a bunch of overhead between them. It doesn't really fuse stuff reasonably. The torch compile that's supposed to reduce overhead doesn't actually work at all for small models, no matter what you do with it, and it's super slow. The kernel code is not code gen, it's handwritten by both myself and contributors. It's not particularly complicated kernel code for most cases because you don't actually need to fuse stuff with the matmls that badly. It's mostly you just need to fuse a ton of activation and sequence-wise functions. And you need to be very careful about CUDA graphing stuff. You also need to be very careful with how you manage memory. All the memory in Puffer is fully static. Everything is fully deterministic and fully reproducible, which is really nice. Lots of other things. So yeah, custom parameterized kernels. Yeah, so all of our kernels are variable shape, and they're still faster than Torch's, whatever Torch is doing. Which, I mean, like, that should be embarrassing for Torch, but what are you going to do? Okay. Huh. That's cool. High draws in a few matchups. Oh, I see. Interesting. What programming languages? I mean, the whole RL stack was in Python. At some point, I started doing, like, Python extensions. And then eventually I realized that that was dumb, so I just went to C. There really weren't any other reasonable considerations. I also, like, I had to deal with the Python C API for a while. That was annoying. I'm definitely most happy with just the C portions of our code. I'm basically always down to just jam some C. Haven't seen nice tables. I have no idea. But this seems like it's fine. These are probably slow-ish, but they're probably okay. The question is, what do we do? Do we eval versus these directly? Do we hope that this is going to give us some other results eventually? Yeah, you definitely don't want to be using Julia for this. That's troll. You definitely want C native speed. And C++ mostly just gives everybody ways to screw up our nice code base. It really doesn't add that much. There's, like, almost nothing I can think of that I want from C++. And if you do want C++, since everything's compiled as CUDA, you do have it right there. But, you know, we just do everything CUDA C as closely as we can inside of that compile unit. I'm trying to think. For versus minimal. It's funny how transitive that, like, non-transitive that is. That's good in a way that you just implement some bots and actually you already get these, like, crazy non-transitive things. Hmm. I'm kind of surprised that we haven't found anything for this that's better on perf. Because I know for a fact that this set of parameters is not going to do much for us with self-play. We definitely don't want to just be guessing hypers either. This is also just not a good way to fit hypers at all, is it? So the idea is that you have some reward coefficients. It's difficult to say, right? Because, like, I don't know how much information I should assume about the scripted agent. If I were trying to solve this in a setting where I don't have a bunch of scripted agents, it gets harder, doesn't it? Hmm. Do you see the problem I have here, guys? Like, it's not like how do we solve robocode, right? I have many, many avenues available to me to solve robocode. The general issue, though, is that we want a robust and stable self-play method, ability to evaluate the quality of a policy with self-play, because you can't really, you don't have a score because it's relative to yourself. You can evaluate it against your previous checkpoints, but that doesn't actually tell you how good it is against any other model. Even if you do like held out evals against another model, that doesn't tell you how good it is overall, because games can be highly non-transitive. And in fact, here's a very simple game that's demonstrably highly non-transitive. So what do we do? What do we do to evaluate this? Now look, with Robocode specifically, I can get a lot of different scripted bots and say, hey, if it beats all the scripted bots, that's probably a good thing. But this is kind of a unique scenario where I do have a bunch of different scripted bots available to me. And if I'm going to rely on being able to evaluate a bunch of different scripted bots, say, during a sweep, that's also not good. Sub-skill of the game. Yeah, but how the heck do you do that? How on earth do you do that? Make sure I'm not running out of credits on Vast. I am running out of credits on Vast. Let me fix that real quick. Okay. Machine is less than $5 an hour, which is not bad. Hmm. Non-transitive. I don't even want to try training against these because they're slow, right? Most likely. Also, they're kind of tough. Like, self-play does give you a very nice ability to bootstrap. The heck do we eval against, though? I could somehow do it as a property of the sweep. That's kind of getting to, like, population-based training type stuff, isn't it? Could we do something with our sweep algorithm is better. Can we do something about, like, which policies get saved or something like that? Like, we allocate one of the GPUs to just run matches. I mean, how do we know which policies are different? Man, it's tough. You ran into Philip? That's fun. Yeah, in a year, I think in about a year or so, it's like you're really gonna see the stuff with Puffer because. So right now, we're really not doing a bunch of flashy demos. We have a few, but a lot of the stuff is kind of mundane looking research. Because we know that the mundane tasks map to the actual difficult parts of the problems that we actually care about, and they're faster to iterate on. So I do expect that in, like, less than a year, it's all of a sudden they're going to be a bunch of flashy demos, and a lot of people on the outside are going to say, "What on earth? Where'd all this progress come from?" But in fact, the progress was quite consistent. It's just that we were doing real work and not just farming demos. So I think Philip sees some of that as well. So I think it's likewise. I think even he'll be surprised by some of the stuff in a year or so. Numbers. Yeah, the numbers are very like the fact that having RL that can solve big mazes without gaming them in any way, like that is a harder eval task than pretty much anything else out there that's used in any real research. Um Sokoban as well, amazing task, but do you reward shape it or not? That makes a huge difference. So there are like all these very key little details that very, very few people appreciate, but it's fine. We don't have to care, right? Like, I no longer have to publish. I only have to care. Well, obviously, we keep our clients happy, but outside of that, I only have to care about progress, like real progress in the field. And then if it takes a couple years before we have things to show that people understand, that's fine. Sounds too good to be true. Yeah, we do kind of have that problem because most things in AI nowadays are just bullshit. So this is not bullshit. You can go download it and try it. Um, it's genuinely just a SOTA policy, SOTA hyperparameter sweep, SOTA implementation, SOTA like everything. And each one of those little components has been months of like very, very hard work. Um, and a lot of evaluation. I still don't know what to do with this frickin' self-play thing, man. Like, you need to just be able to compare. Like, you need a real ELO number. What changes are you trying to make to self-play? I'm trying to make the changes in which it works. Limiting. I already have that liberty. We have that under domain randomization. That helps, but it's not enough on its own. And, like, to be fair, I could probably solve a lot of individual problems by going very far down that route. But that's not really the core question at the moment. Hang on. If you're just training against checkpoints, hang on. If the pool is all of the checkpoints from a sweep, that should give you a lot of opponent diversity. Multi-round system? What do you mean? It's got to be something here, though, with, like, training against all the other agents from a sweep, right? But then how do you separately... The sweep is supposed to find the good hyperparameters, right? if why not hire a couple of researchers? So, I mean, Spencer's now working on this with me. He did the original historical self-play implementation on this that I'm building on. He's working on other client stuff. And we just had Finn join us on Monday. He's here for the summer as an intern. We could try to scale it faster, but if I tried to hire a bunch of people, I'd have to take VC funding. And it's essentially the strings attached to VC funding are, and the constraints that that place on what we can do make it not worth it. And it's easier for us to just grow slowly and to be, consistently profitable and not to have anybody else essentially setting our research agenda. And so far, it's been tremendously effective, right? The types of problems I'm solving, there really is not a single person in the world who I would say, oh yeah, if I just had this person, they'd solve it immediately. What do I need to do to join? You just contribute to the open source stuff, man. I mean, that's basically what Finn did. Finn pretty much just like sent us the best PR we've ever received and then asked for an internship, and I was like, okay. A little bit, Jess. No, Finn is remote-ish. We don't have a physical office. I don't see the point in doing that. I myself don't like being in the same place all year either. One of the nice perks of doing your own thing is you can kind of work from wherever. So I kind of move around every few months. I need a change of scenery. I think playing against the checkpoints from a sweep, that is onto something. Now, are you work alone or with co? I mean, it's a big open source project. You can literally join right now. Just discord.gg/puffer and start slinging code our way. Thought we already did that. No, we did the exploiter agent thing. We did historical self-play. We have not tried sampling, like treating the sweep itself as the thing. Yeah, exactly, Jess. Well, it's annoying in a sense, Jess, because you're mixing two things, right? Like trying to find good hyperparameters and building out the set of opponents. It also would mean that the experiments get incredibly expensive very quickly, right? Because now you have to do a full sweep to test anything. So I guess you can keep the same frozen set of opponents. Kind of assumed we'd have a better solution. Yeah, there is not a better solution that I see. I mean, this does seem very inefficient in a sense, though. I wonder if we can do... curricularizing... the difficulty arch... The problem we have is not, like, can we learn against a fixed opponent? The problem is getting diversity into the policy. So we can crush basically any fixed thing that we train against very easily. DeepMind does what? The annoying population-based training stuff, right? So janky, though, man. The heck is the alternative, though? Also, why is this so difficult? I guess it is genuinely possible that robocode is actually a pretty tough task. Very non-transitive. It's probably this is a pretty tough task for self-play. Okay, that's at least nice, right? Like, it's not like we're having a tough time on an easy task. We haven't tried it with an easy task, Jess. But the thing is, any task that doesn't have any sort of strategic diversity in it, this will just solve. Anything where it's like, yeah, there's one solution or whatever, one reasonable solution, this will just solve it. I'm pretty confident in that. We don't really want an easier task. Like, this is... I think this is ideal for self-play from chess. Well, Arch, this is not a turn-based game, so other than that, no. But that's the key distinction. This is not turn-based. Hyperparameter sweep, we get different. That is likely, isn't it? You get different policies, different sweeps. But then what's the metric? Doing this game engine RL hybrid in Rust. RL in the engine, currently using this library called Burn. They're only comparable to torch and speed. M's in Puffer. Only on PPO. It's not only PPO. We have some very major algorithmic upgrades to PPO. We tried some stuff in search-based methods. It's generally not the case that just search is better. Search definitely lets you spend a bunch of compute. It's unclear that that is often, or a reasonable chunk of the time even, a better thing to do. I will say our baseline learning method is ludicrously strong. Like, Puffer 4's learning method is so strong that we actually have a tough time coming up with tasks that it can't solve for Puffer 5. Like, well-posed problems that are fast, we typically just crush. Man, this is tough. Okay, hang on, right? We can train a goddamn 100 million steps a second. Okay? I fix some of the coefficients. We should be able to afford... We should be able to make an entire sweep fast. I think we can make an entire sweep fast. How many experiments could I reasonably run? Like 100? 100x 100 mil is 10 bill. 10 bill is very fast. So the thing is, if I can I can genuinely do entire population plus sweep if I can define it cleanly. We have one worker that's just updating all the ELOs. We have 7 workers running experiments. We look for higher ELO. Does that do it? I mean that we can genuinely do 100 experiments. Like, we can do 100x 100 mil very quickly. If that's what it takes to get us, like, the training diversity. How would that work for longer time ranges? No idea, Jess. Let me go check this thing. I'm seeing why they've done this. Though I actually, man, this could just be such a big nerd snipe is the problem. This has no sections. It's annoying in a sense that this is basically just exploration. Yeah, this is basically just exploration coming back to bite us, and just happening to bite us extra hard because it's multi-agent competitive, right? If we were gonna run a sweep, and assume we get a held out evaluation. Hang on. Let's assume that we have a sweep with a held out evaluation, okay? We elo rank those. We throw out the crap ones. I think that's reasonable. I think that's reasonable. We sweep self-play versus bot 1. Okay. Here. Yeah, this thing fucking sucked, so that didn't work at all. Sweeping versus this did not help. This is what we're gonna do, right? Train a model versus... We do a self-play sweep. Take DR off for now. If I do num agents, num bots, 1. You gotta not get totally lost in the sauce here. This thing requires a held out evaluation, but I think that you kind of need some sort of held out. You can always just make it like whatever the best bot you have so far is. I'm gonna enjoy this more than the 5.0. Well, I enjoy thinking about stuff. I hate like type shit into codex, wait, type shit into codex, wait. Okay, this is learning. I'd rather it not take a billion steps. I really would rather this not take a billion steps to fucking train. Yeah, so definitely learns in 500 mil. Let me just hack this a little bit. Is there a good way to deal with transitive policies? Historical self-play solves transitive like strategy cycles. They're like dealing with transitive is not the problem. The problem is just finding all the strategies to train against. Training against everything is sufficient. Okay, there you go. This solves in 100 mil. And this has a kneeling off as well. So we can just solve. $5 mil SPS is kind of shitty. But hopefully this trains. Yeah, this train's 75. Okay, that is a policy. And we will do two, 0. I noticed that using a 90-10. Wait, a 90-10 loss split between a cumulative loss function validation loss. I was able to isolate plateaus much faster independent of. What? I don't know what you mean there. I do not know what you mean there. Much faster independent. That could help. Yeah, I'm not following that. This is like self-play RL setup, yeah? Uh... Survey on self-play. Didn't somebody link that earlier? Is it the... I forget if it was at Tsinghua or a different Chinese university, but like... It was this very weird theoretical framework. I've seen 2 of these types of studies, and neither of them were, in my mind, particularly useful. Ah. Exploded after LMs. Lovely. Very annoying, I will say, to figure this out, but ah, heh. Well, I mean, this was a pretty obvious don't invest in a programming language by company. I mean, it was not a good programming language in the first place. It was like this weird Rust in Python bullshit. Why is that bullshit? If you're new around here, I'm not a fan of Rust. I fucking hate that language. It introduces a huge amount of complexity and forces a specific programming model in order to avoid a class of bugs that, like, does not even exist for the most part in very, very um, large spaces of program design. Like, memory bugs just aren't that big of a deal for a lot of different applications. Like, C is just so much simpler. Jess is memeing. No, I like the way that C does it, where you have like a compile this into a slow binary with a bunch of checks, or compile it into a fast binary without a bunch of checks. It's perfect. That's all you need. Like, the complaints I have in C are, I like there C is not a perfect language. There are a few small things here and there, but then, like, everybody that tries to fix the problems with C goes way overboard and ends up creating some so-called modern monstrosity. Okay. I've got until 4:45 today to stream. C minus. They should have just called C plus plus C minus minus. It's annoying because C is just like C is an awesome language, and then C plus plus is such an awful language. Can we add a max? Can we add a max time per end for a max time per experiment? Python C CUDA percentage split and Puffer. Um, you can ignore this because this is Torch. This is also experimental crap. This is also, like, these two are also to support Torch. So we have, I believe it's like less than 2K lines of Python and 5 or 6K lines of CUDA C for the training. Training, it's like a mix of CUDA and C. We don't have C files and CUDA files. Everything is just in CUDA files because you end up writing much more succinct code if you do it that way. And then like some ungodly number of lines of C code for all the environments. But those grow horizontal. Like you do not increase the vertical, like you don't increase the complexity of the stack adding more M's at all. Yeah, the CUDA GP stuff will be, I mean, basically the goal is by Puffer 6, the amount of Python required will be 0. 9, 80, and 7.5. Yeah, because it's counting the envs. So obviously with the envs, but it's counting like tests for Python as well, which are throwaway garbage scripts that nobody cares about. Um, I think it's like actually 5, 6K lines of CUDA C for the training, and then like sub 2K lines of Python. Put a cap on this. Proper check on protein. That would be very nice. Read the blog post for the motivations. Like, I understand that we're ignoring the entire math behind acquisition function. Like, I understand that we're ignoring all of that. But, like, you have to actually be able to get me a reasonable estimate of variance if you're going to write something that makes use of the variance, right? That was kind of the key finding with protein, is that carbs was depending very heavily on having an accurate variance estimate in the Gaussian process, and the variance estimates were basically garbage. That's not much code. Yeah, we worked really, really hard to get it down to what it is. Um, that's kind of the whole point, right? Like, 5K lines of CUDA C replaces 3.3 million lines of Torch, and it's 5 times faster. And that's 5 times faster than the optimized Torch from Puffer 3. It's like many thousand times faster than anybody else's Torch that's not Puffer's. Dead end for similar issues. Well, I mean, the Gaussian processes are perfectly reasonable. It's just you don't trust the variance estimate. If you have anything else that will work instead of a Gaussian process just as well, like, by all means. I mean, you have a very easy way to test this as well, right? Like, you can go put like a 10 to 15 second cap on the experiments for breakout, because we know that breakout can be solved in 3 seconds, so like 5x. Give it a 15-second cap, get an 8 GPU machine, and then you can run like a 200 experiment breakout sweep, right? It's very easy to test the sweep infrastructure. Just be careful that you also test it on other envs once you think you have something, so you don't overfit one env. Like one env of sweep. Those approximations. Yep. Yeah, I don't much care for fancy math that doesn't work. I tolerate fancy math that does work. I don't know. I started off thinking that I would need a ton of math for ML, and then like I started taking courses on ML, and they taught me a bunch of math, and it was really fucking hard, and it was completely bloody useless. It didn't work on any real problems, and I started learning more engineering, and I started being able to solve problems, and like it felt like I could solve very hard problems if I just knew more engineering. So I spent more time learning engineering, and that's how it went. And even today, it's very very rare that I see you know I see like a very math heavy breakthrough. You often see breakthroughs that are entirely empirical and then have math retrofit to them. I think the only thing I've seen lately that was um very mathy and genuinely very good is Muon. I think that's basically it though. I tried. Aurora didn't do anything for us. Arch. I tried that. It didn't really help. Pretty much, crit. Like almost always. The vast majority of failures that I see in like published research, it's not they got the math wrong, it's almost always they completely and utterly failed to program anything. No, not even with speed arch. Oh, I think I did get the Polar Express thing, but not the broader method. I don't know if the Polar Express thing was Aurora though. I thought that was some other that was originally from something else. Okay, let's kill this. Come on. Hey. Okay. I think I figured out what's happening here. Boom, 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 boom. This we can do like this. Maybe. Buffers, threads. We'll see about this. Okay. And okay, so we should hopefully be getting some data here. Mm-hmm. So the idea is if we can just run a sweep, if we can run a sweep versus the a self-play sweep with held out eval. First of all, we should get some policies that at least do okay on the held out eval. And then specifically, we should be able to train a final policy against all the previous ones. I'm hoping we can do something like that. That seems decent to me. This is a quick sweep as well. Like, this population-based training thing is very irritating. Yeah. Because without the self-play, okay. Yeah. I think it's roughly correct. Okay. I think this is good. Right? We get bot perf. 9%. 75 mil steps. And then it'll sweep for this. And now I suppose we'll just see whether this finds anything better, huh? And then we just run, we run like a big elo calc type thing. And anything that's not significantly better than random just gets ditched. And then we'll train against that. That seems reasonable to me. Heh. Alright. I think... How long are we going to let this run for? They're pretty quick runs. We're getting 8 back a minute. We are progressing. I'm going to use the restroom real quick. I'm going to come back. And I suppose we will see... We will see from there. I guess... The one thing that does bother me a little bit here is the number of just crappy runs that we have. We'll think about that in a bit. I'll be right back. We'll think about that next. Here's my best guess. It's probably like some sort of constrained hyperparam search, right? And I think that you're probably at some sort of constrained hyper search. Let's go look. Mutated versions of better agents. I want to just see, they have, no, they don't have. I want to see what they, exactly what parameters they tuned with PBT. You probably just would like fix some basic parameters, maybe. Have we seriously just not found... Okay, at the very least, this is a different set of parameters from the defaults. So that is good. But are we actually finding, like, better params over time? We have 100 experiments. I was hoping that we would have, within 100 experiments, we'd have something reasonable. I guess it is self-play. Oh, there, we just got a new one. 15%, much better. So we'll give it like, we'll give it some more experiments. And I think what we'll do is we'll run ELO across all of these. You know, we just run a bunch of games across all these. Oh, also, yeah, we'll take the best one of these and scale it up as well. That would be nice. Yeah. Ah, hang on, this num threads thing is annoying. Okay, well actually that actually does clear one thing up. Okay, I messed something up with this threads thing, but that's fine. That will bias it. I think this has a reasonable shot of working. I guess I wonder if the policies will be strong enough. It just depends on the strategic diversity, I suppose. Can almost never reach vertically. It's not just like a 0-1 reward crit. It's you get a reward for making the top part of the pole go up. They were using when Yassine was doing that, he was using a dumb reward function, so I just gave him a better one. I was like, here, try this, and that's what everybody's been using as far as I know. Like, reward engineering is massively overstated. You really don't need to do very much of it, but you need to at least not be completely dumb with it. 15.9. Okay. This is at least interesting, I think. This should be interesting. We'd give this thing more threads and like maybe a 5-minute budget instead of a 1-minute budget, but I think this is basically what you need. Small velocities. Yeah, but it'll figure that out, man. You don't need to mess with that. It's basically a full 150 experiments. Okay. Mess with this. I think it's just going to be run big tournament, see how Elo is. Proceed accordingly. And we will see. What in the actual hell? That's fake, right? Jesus. What the hell? That's obscene. Wouldn't the super fast ends be interesting for AVO algorithms? Yeah, in fact, I would say that's the only way that Evo would make sense at all. Even with stuff being super fast, I still don't think that that line of work is in general super promising. It's cool, but unless you find some way to do it that isn't multiple data, multiple instruction, like having to have a whole bunch of different neural nets is just not, that's not how GPUs work. Basically doing everything on batch size 1. I don't know if is there a way you could make hardware that like makes sense for that? Like in theory, could you make hardware that just has um a ton of like batch size 1 optimized units where you just keep a whole bunch of different sets of weights on it? I don't think so, but I really don't know enough about hardware design. To be fair, I think that is actually the level of thing that you would need to know in order to like flip all of modern AI on its head. You'd basically have to come up with some architecture that or some algorithm that nobody else is bothered with because it's incredibly inefficient on GPUs, but you know that you can make a chip for it that would be very, very efficient because you know about hardware design and nobody else in AI does. And you'd like prototype the thing slow, get the flop or whatever, like compute equated result showing that your new method is good, and then you'd go run, like, do your own chips for it. That's how you'd have to do it. That's like the level of thing it would take to flip modern AI on its head. Hello, welcome. Like, you'll see how something like that is not completely stupid, right? If you just go deeper, like, if you just absorb more of the stack, essentially, the more of the stack you take into consideration with a design, um, the more likely it is that nobody is going to have thought of that whatsoever before, or like nobody is going to at least have like, thought of it and then also put in the effort to go try it. It's actually pretty rare that you can just like change one small portion of the stack and have a massive contribution to anything. But like the more things that you're willing to touch and redo, the more likely it is that you actually come up with something that is groundbreaking. I use Pufferlib for WTA multi-agent. Results is really good. What is WTA? I'm glad Pufferlib is working for you, though. Okay, we're letting this thing do whatever garbage. Weapon target assignment. Alright, cool. Entire country defense. Oh, Pufferlib now defender of nations. Ish, cool. We're working on multi-agent right here. This is, I mean, this is essentially a programming game, but it's like this tank battle environment. And we're using this to figure out self-play. Okay, we have plenty of checkpoints now, right? Pufferlib is protecting Turkey. Oh, maybe if I show up If I'm ever in the area, somebody will treat me to some Turkish coffee then. That's cool. Eating with TPU. I don't know if quantum is anything, to be honest. And TPUs, no. TPUs are just like, those are designed for the current architectures. Those are basically just competitors to, I think TPUs are basically just competitors to NVIDIA GPUs. Okay. That's enough experiments. Okay, cool. Hopefully this doesn't OM crash us and be shitty. We're just going to do this. Fun. Okay, this is decently quick at least. I do wonder if 500 rounds will be remotely near enough. Probably not. I played the demo, but I only played it for one evening. It seemed fun. I had fun with it. I don't really play puzzle games that often, but I'm sure when the full game comes out, it'll be something I'm in the mood to play at some point. I don't know. I was expecting it not to just be like Sokoban though. I was expecting it to be rather different. So I think it's not all just Sokoban, is it? I don't know. When I heard it was like, oh, it's going to be 1,000 puzzles, I was thinking like, yeah, it's actually 1,000 different puzzles, you know? Oh, very possible, Arch. With something like that, yeah, very, very possible to do that. Like one quarter of the world. Okay. So if it is actually like four separate different like things with that's cool. Four types of puzzles with building mechanics, like maybe not an we'll see. We will see. I was having fun with it, which is funny because I fucking hate puzzles. I'm kind of a philistine, to be honest with you. Like I play RuneScape, okay? That's what I fucking do. Are his games actually good? I mean, I had fun with it for the few hours I played with it. You didn't need to make a new language for it, but like, am I happy to see people doing shit in like not god awful Unity or Unreal and like actually caring about performant code? Yeah, that seems cool. And like, does it seem like a reasonably good game as well and obviously performant and such? Yeah. Um, it is kind of a meme to make a whole language and then ship a demo that like doesn't even fucking have Linux support. That was kind of weird to me, but okay. The language like looked okay. There were a couple things that got me sort of thinking, okay, that's interesting. Um I think overall it was too much. Like you like way 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 far of a departure from your typical low level that just supports things that aren't really needed. But there were, there were a few cool things. Low latency, C++. I don't. Why C++? Why not just C? C++ is a very shitty bloated language. Save 20% lines of code. No, usually, so maybe with small projects, but with big projects, the C ends up being shorter. Because just people lose track of shit in C++, and they end up bloating it with abstractions. And that's how you really blow up code base. That's how you really blow up code bases, is by just losing track of what the hell you're doing. Like, the reason that projects are massive, it's not because, like, this string operation was 3 lines instead of one, right? It's because you're doing these million things that don't even need to be done if you re-architect the program like this, which you couldn't see because you have these other million things going on that also don't matter. Oh, this is an interesting ELO spread. We'll see how this experiment works. I think this is going to be the main thing that I run for today. So, hopefully we get something out of it. If not, I don't really know. Entire quant, HFT Corp, use C++. Um, yeah, large number of people doing a thing and large number of people that make money doing a thing is not at all a good indicator that said thing is smart. You learn that very, very quickly if you interact with any of the big companies. Like, I don't think that there is a single big company in the world where the average employee is smart. Like, even the average employee in a technical role that is supposed to be smart is smart. I don't think there's a single company in the world where that is true. Small companies, yeah. Startups, yeah. Big companies, nah. You don't scale and keep talent density ever. I've seen zero exceptions. Self-play rise for this run. So, hear me out on this, Ryan. So, what we did is we have a sweep where every experiment in the sweep is just basic historical self-play. All right. And then the sweep is evaluated, like each experiment is evaluated against a scripted bot. So the sweep is trying to optimize perf against the scripted bot. And then what I'm going to do is I'm going to try to train I'm going to do a bigger run where I use all of these different checkpoints as the opponents. And I'm going to see if that gives us the robustness or not. So we just do a big sweep. We elo rate all of these things. We keep all the ones that don't suck. And then we try to train against them. Isn't that like training a bunch of exploiters? Nope, none of them are training against the scripted bot. They're all training against themselves. So it's a bunch of different self-play runs with different hyperparameters. We eval them against each other. So the only thing that has to be true here for this to work is that, like, hopefully if you do a sweep, you learn different strategies. Yeah, exactly, Ryan. Train self-play validated against a scripted bot. This is basically just the coolest thing ever. I don't know, I'm pretty bored, frankly. Like, this whole sort of thing is kind of boring in the sense that I sort of have to just guess here because there really isn't any literature I can rely on for this stuff. Um, I'm kind of just trying a bunch of things that seem kind of reasonable, and if none of them work, we're just going to end up having to go back to your standard historical self-play, and trying to, like, DR our way to victory. Ryan, do you remember the hyperparameter paper, like the hyperparameter diversity paper? I'm kind of hoping there was something to that at least, even if only a little bit. like the different hyperparameters learning different strategies thing? I thought you were on that paper, maybe not. Was that the same paper? My apologies if this is like asking you like, hey, do you remember Vietnam? Man, wasn't that a fun time when Americans made like a $20 submachine gun? Yeah, I think that's what it was, Ryan. Almost done on eval. I mean, Ryan, in my mind, like, we basically have nothing to go off of here because the deep mine papers are super bloated and cost about $1 trillion in compute, and their methods are never super trustworthy anyways. The OpenAI ones just use the simple methods that don't seem like they work, so they probably just engineered their specific problems into working. And all the other papers on this topic are crap. I don't really know what the hell else to do. Yeah. Oh, I have an idea. Let's just go ruin Yassian's life real quick. One second. Where's this damn thing? What the heck? Where's the stupid Dota tweet? He posts way too much, man. Holy hell. Is this literally from... These are the last 2 days. All right, cool. Yassine's been his life's over. uh, trying to make Daphne's paper makes me a little more confident. A self play. Wait, her paper was human data, right? Okay. AI will implement Dota efficiently. No fucking way. Nah. Equilibrium selection. Hmm. Dota. They seem to have added too many new. Well, I mean, so does League. Like they have to do something every so often, because it's like the Dota players just play Dota. They don't play anything else, so they need something every so often. Seen any material worth reading in RL for low signal very low signal noise like trading? Um, Not domain specific to that. I have a good general RL reading list on my X. What? I see. Intermix, especially around the random anchor. Oh, I see. But everything is better than random, it says so far. It's interesting. Hmm. Okay, well, these take forever. I think we would just try it versus random then. That'll be quicker. SpaceX tanked like crazy. Did everything tank or just that? Entire strategy space with one new mechanic? You don't really... You shift the meta for sure. Core mechanics stay core mechanics. This is my... The original was my advisors. That's funny. 600 billion? I don't know. I personally... Not financial advice. I thought that, like the XAI portion was massively overvalued, but SpaceX was undervalued. What environment am I working on right now? This is Robocode. If you look it up, it is a like 20-year-old, originally in Java, now ported to Super High Perf C, like tank battling game. It was meant to be like you script a bot and then you like fight other people's scripted bots. But it's strategically, it's kind of interesting. It's a really good self-play game for RL research. And I'm using it to try to figure out how we come up with like a good stable self-play routine for Pufferlib. Also, for anybody new around here, start Puffer on GitHub if you haven't already. What are you doing? It's free. Feed the Puffer a star. Thank you. What do we actually add? I know we hit 6K finally, which is so cool to have that. Not bad. 6047. Ray GUI is very nice. I think that's good. Ban AI in programming competition is reasonable. Astrid guy? Who? I was looking at Saiho. I have no idea who this is. It was a random, follows me apparently. I have no idea who this is though. Saiho is former, OpenAI on Dota. He's really cool. Highest MMR rank in Dota. Like, unranked, my guy. I played it for a week before the OpenAI 5 finals just to get some sense of the game. I'm like hard stuck iron on League if I ever do play that. Though realistically, I'd probably land back in bronze if I actually played it consistently for a few weeks. I am not good at many games. The only games I've ever been top 1% in are MMOs. Is Google falling behind in it? I mean, they kind of haven't been doing stuff for a while. I actually, if I had to pick, like, the single AI company that I care about the most nowadays is DeepMind. DeepMind is still cool. Which is sad, you know, man, because back in peak OpenAI days, OpenAI was way better than DeepMind. Like, when they were doing Dota and stuff. The DeepMind guys are just too mathy. They can't resist the urge to, like, overcomplicate the crap out of the algorithm no matter what they do. And it really makes it difficult to see what pieces of their discoveries were necessary versus what pieces of their discoveries were just them nerding out. OpenAI was a lot better at that, but now they don't do anything anymore, so. Google Brain was like, okay. Most of the good stuff was DeepMind. And to their credit, DeepMind still does lots of good stuff. And there's spin-offs as well, like Isomorphic, it's apparently doing good stuff. David Silvers, I have no idea what he's doing. If you wouldn't mind solving a couple of these annoying RL problems, that would be nice. Maybe I'd have more spare time then. Access to EVE Online. Man, I don't know, like, I think that that's mostly bullshit. Like, they're gonna come up with some crazy looking thing, I'm sure, with LLM agents, but it's way less impressive than things previously done without them. TCP. Well, that's just Evo. That's just a game, right? Whoever the hell owns. Um, I don't know. I remember I said like almost a decade ago that the next obvious environment for RL was an MMO, and I started building one, and just like for whatever reason, nobody caught on to that, and well, now years later, we've kind of shown many discoveries came from that line of work, but they still sort of didn't catch on, and now they're just doing LLM crap. Some of these policies look okay. Yeah, I don't think there's anything shady about that though. I think that's just like whoever the hell happens to own the game, right? Hopefully we can finish up the experiments for today soon. I think I have pretty good idea of what to do here. It's a little bit annoying. It seems like we have some good policies from here, but not too many. Eh, I guess what we take anything with like 75% win rate versus random. Oh, you should be able to get 90 plus so easily versus random, no? I guess we'll just count the number of both. How many are 75? How many are 90? So it does seem like they're either really bad or like 90 plus anyways. So probably we can just use 90. There are not that many policies that are like 70% that I see. RL insights which come from puffer M's, even translatable to LM RL. Maybe, maybe not. I don't particularly care and I haven't really thought about it. RL is valuable, very much so independently of LLMs. I like the 3D puffer. Ooh, puffer. We love our puffer. He's our mascot. We do have a like touched up version of him as well. By we got an artist to like fix up a few things with the model. I have to like mess with the lighting though. So I haven't like it'll probably be part of our like next update or something when we get the new puffer in. But he looks basically the same as the old one. Like we're not getting rid of this one. We like our fish. It's just stuff like the fins not connecting to the body and stuff. Puffers are toxic. Yeah, fugu in Japan. I don't know why on earth you would eat a pufferfish. Like, they're so friendly, and they're not tasty, and they're the second most poisonous thing known to man, so why the hell would you eat that? Like, leave the puffers alone, you know? Nobody goes around trying to eat golden dart frogs, right? I think blobfish just look gross. I don't think those are poisonous, are they? And I don't even think that they look gross. I think they look gross, like, out of water. The eyes. Do full RL approach. Oh, yeah, yeah, I saw that. I don't know what full RL approach means, though. Like, I sort of just assume that most companies are going to do nothing until proven otherwise. Even when they're started by good people. Unless they're unfunded, in which case, then yeah, they probably produce stuff. Oops. Hopefully we get like, what, 10 to 20, maybe 30 that we can use. Takes forever to run evals, though. Eh. I mean, this is a stupid script. We could easily... If this is the right approach, we can very, very easily speed this up. Hey Jess, we are realizing that we can't run a massive ELO tournament over all these checkpoints, and it's much more practical to just filter out ones that don't beat random policies. We can just filter out essentially all the failed runs easily enough. Paper with Sutton. That'd be cool. Though with the funding, yeah, this is the problem, Tinkers. I mean, he might be a big enough name to just, like, get a few years to tell people to fuck off and let him cook. But, I don't know, I'd be somewhat surprised. Yeah, you'll see that there are a lot of startups, though, that originally start doing something cool, and then they just end up doing the bog standard thing. Wait. There are a ton of companies doing that, Crit. That is the bog standard thing. Welcome. $60. Okay. Uh, we need some hypers, don't we? What on earth is that question? How much slower do you think this will be on single GPU? It's like it's pretty much linear, Jeff. 8x for 8 GPUs or like 7x. And I gotta go in a minute as well. But I think we've basically set the stage for this. And if this doesn't work, then we go back to dicking around with historical self-play and we've run a bigger sweep, I guess. Fixing RL. I mean, I'd say the puffer community is as a whole at the very least. I think like puffer plus open source with a few people. Yeah, I think RL will be set within the year. Not the calendar year, like within 1 year of now. Could be a little less. Depending on how much we get distracted by business. Oops. And I need 8 threads. Like this, right? Buffers. Oh. Business versus research time split. So it depends. Like right now, for instance, I would be doing different research, except that this is needed for some client work. So I'd be doing 4.0 instead of doing, I mean, I'd be doing 5.0 instead of doing this like other self-play feature. So if you count work that has been prioritized for companies, it's probably like 40% of my time. But if you count work that's just directly for companies, it's like 20% of my time. Maybe just to be determined. No free papers up for grabs. Academia's a bit fucked. There's no incentive. There are plenty of free papers up for grabs, man, if you just want to, like, do a thing but with Puffer. It's just that I don't particularly care to do that anymore. Like, I have better stuff to do. I'm done publishing. Like, I have wasted enough of my life fighting reviewers and going through stupid procedures for no reason. I'm still gonna write stuff, but I'll write, like, blogs, I'll write, informative articles, I publish analyses. I mean, I have lots of articles on my X about our research. Well, there are some people using Puffer for stuff. We have, like, Google, Scholar, Puffer Lib. 16. I don't know which one people are citing. There are few. Won a Best Paper award. Yeah, we have collabs with Eugene. Like, we have Puffer Drive is the new driving sim and all, right? I gotta go to dinner in a minute. With Puffer. Yeah, Puffer 4 is very nice already. Like, you don't even need 5 to do stuff, honestly. Okay, so versus bot goes down. I believe this is a correct eval. Okay, so first differential geometry. Heh. Yeah, that's rip. It's annoying doing like in academic stuff. You never have time to do proper engineering. But then the reason you never have time to do proper engineering is because you haven't done proper engineering. Yeah, you can kind of just make shit up, and there's like, yeah, fancy number, doesn't replicate whatsoever, but yeah, sure, we saw this number at one point during some of our experiments. The laptop. Um, yeah, gaming laptops mostly fucking suck, I'm gonna be honest. I always insist on having one because I want a local GPU, and it always fucking sucks. They just die after a few years, even with light use. The cooling on them is just so ass. Honestly, that thing, like, the Steam machine, that, like, this actually seems completely reasonable to me. For this form factor, like, this is completely reasonable. Even worse. Okay. I'm gonna call it here, guys. I've gotta go, I gotta get dinner, and I gotta get there. Um, we're pretty close to having this thing set up. I have no idea whether this will work or not. We're basically just seeing whether training with a bunch of policies from self-play on different hypers actually helps us on held out eval a lot. Um, if not, I guess we'll just come back tomorrow with more domain randomization and stuff, trying to just see, okay, if we have to do M-specific work for self-play, what's the minimum we can get away with? So we'll see how that goes. I'll see if I can get some sweeps overnight. For everybody who's new around here, though, please start Puffer on GitHub, puffer.ai. The GitHub is right here. Join Discord if you want to get involved. Follow me on X for more RL content.